Hello again. We are continuing our readings from the book What is Man? Adam, Alien, or Ape? And we have arrived at the beginning of chapter 3, which has a joke title, Small Flat Bugs, and a serious subtitle, Where is Man? Now, in reading chapters 1 and 2, I did not read the synopsis that appears at the beginning of every chapter. And the reason was that it was somewhat redundant once one has read the chapter. But I'm making an exception for chapter 3 because I think the synopsis is probably very helpful in leading us through this chapter and indicating what it's all about. So here we go with the synopsis of chapter 3. It's easy to confuse SETI, that's capital S-E-T-I, with Yeti, capital Y-E-T-I. It's easy to confuse SETI with Yeti because both relate to creatures that probably don't exist. The Yeti is a proverbial beast that inhabits the Himalayas and walks upright like a human but leaves huge footprints in the snow and strikes fear into the local populace. Related to America's Bigfoot, it is sometimes called the abominable snowman. SETI, on the other hand, stands for the search for extraterrestrial intelligence, the hunt for an intelligent alien who is so unlikely to show up that he might, with some justification, be called the abominable no-man. Yet nations around the world are currently spending eye-watering sums of money looking for him in distant galaxies and building bigger and better radio telescopes to further their quest. Why, I wonder, would they do that? The answer is that SETI scientists and the governments and institutions that finance them believe that the discovery of alien intelligences would help answer our question, what is man? For example, the European Space Agency claims that its new extra-large telescope, quotes, will answer fundamental questions regarding planet formation and evolution and will bring us one step closer to answering the question, are we alone? Apart from the obvious scientific interest, this would represent a major breakthrough for humanity, close quote. So in this chapter, we'll trace the history of SETI and its less ambitious but no less expensive sidekick, the search for any kind of life outside of Earth itself. Driving all this endeavor is the belief that finding extraterrestrial organisms would discredit the idea that God created life. It would do no such thing, of course. If God created life on one planet, he could do it on another. Finally, we learn just how wonderfully planet Earth is suited to sustain life of all kinds. including our own intelligent selves. No other planet in the solar system can match its unique habitability, and the same is true of the thousands of extrasolar planets that have been detected to date. As far as we know, Earth is uniquely hospitable to life. Well, that is the synopsis, and here is the chapter. Where is man? And the quotation at the beginning of the chapter is, found a planet like Earth, but 5 billion years away. Best chance yet of extraterrestrial life, close quote. So ran a headline on page 3 of the London Times newspaper on the 11th of November 2009. Later, the same day, a BBC TV news correspondent solemnly declared that the new planet was probably inhabited by, quotes, small, flat bugs, close quotes. The 5 billion years was a miscalculation by the Times. It should have been 500,000 light years. But what difference does a few zeros make to a gullible public? Furthermore, you must understand that the bugs in question have not actually been seen, nor, come to that, has the planet, though its presence can be inferred with a fair measure of certainty. But small flat bugs, no chance. As Mark Twain once pointed out, quotes, it's amazing how, for a small investment of fact, one can get such a large return in speculation, close quote. The slightest hint of life elsewhere in the universe, no matter how unlikely, sends the mass media into a frenzy, with NASA, which should know better, not far behind. Subheading: Exoplanets. Atheists like the idea that Earth is just one of a countless number of similar inhabited planets in the universe, because if true, they argue, it would diminish the significance of life on Earth. This, in turn, would remove the need to think that man is anything other than an accident of nature. So let's pursue our headline and consider the current excitement over what are called exoplanets, planets that exist outside the solar system. First, what are the facts? The search for planets orbiting stars in distant galaxies is a large and growing area of astronomical research. At the time of writing, the online Extrasolar Planets Encyclopedia lists some 1,000 cosmic planetary systems containing over 2,000 planets, which are known to be orbiting stars other than the Sun. These numbers increase almost on a weekly basis. I should add there that number is now something like 5,000 exoplanets. At the time of writing, it was only about 2,000. How do they know? Most of these exoplanets have been detected using the radial velocity method, which uses spectroscopy to measure the wobble of a star caused by an unseen planet's gravitational pull. The second most widely used method is the transit method, which measures the tiny decrease in apparent brightness of a star as the planet passes in front of it. Both methods allow astronomers to work out the mass and orbital characteristics of the exoplanet, while the less reliable transit method also allows the planet's size to be estimated. The exoplanet featured in our headline is one of three believed to be orbiting a red dwarf star called Gliese 581 in the constellation Libra. The planet, graced with the catchy name Gliese 581c, was detected using the radial velocity method. That is, it has not actually been seen, but its presence is inferred from small variations in the star's radial motion, deduced from effects in its light spectrum. Its discoverers claim that Gliese 581c is a rocky planet with a radius 50% greater than Earth and about 5 times Earth's mass. They estimate that its surface temperature lies between -3 degrees centigrade and 40 degrees centigrade, which places it within the habitable zone of its parent star, because liquid water could exist there. And if a planet has liquid water, they argue, then life could have evolved on Gliese 581c, as it did on Earth, quotes in quotes. But why might it be inhabited by small, flat bugs? Because with a mass 5 times that of Earth, the planet's gravity would also be 5 times greater, enough to flatten even a bug. Why small bugs? Perhaps because an uncritical public are more likely to swallow small bugs than little green men. I should make it clear that the planet's discoverers said nothing about bugs. That was an invention by the British Broadcasting Corporation. But their claim that Gliese 581c is a rocky planet like Earth and has liquid water on its surface is itself based on a string of assumptions. An informed website respondent commented, quotes, "You must remember that neither the mass nor the radius of this planet are actually known. The mass is the minimum mass, since the radial velocity cannot determine the angle of the system. The mass could actually be larger. I would not be surprised if it turned out that these planets are all Jupiter size. The quoted radius of 1.5 Earth radii is the size the planet would be if it were terrestrial, that is rocky, which is not known. We actually have no idea what the density of Gliese 581c is." Another astronomer points out, "The habitable zone isn't a terribly robust definition. The inconsistencies in temperature calculated by different correspondents are due to assuming different albedos, that is, how much of the incoming sunlight energy is absorbed. I think a more important difference is the greenhouse effect, given that many of the most abundant molecules in the galaxy are greenhouse gases." Close quote. Subheading: Mars and the search for extraterrestrial life. But let's leave aside the ill-informed enthusiasm of the mass media and turn to serious science. The search for extraterrestrial life, SETI, goes back over a century. In August 1924, when Mars was its closest approach to Earth, a 36-hour radio silence was observed in the USA for 5 minutes every hour to listen for possible radio signals from Mars. The US Army's chief cryptographer was even assigned to translate any Martian messages that might be detected. I imagine he was quite relieved when his services were not required. This may all seem rather quaint to us, but let's not forget that while we no longer expect to find intelligent life on Mars, the search for more humble life forms there, extant or extinct, continues unabated. As part of the aptly named ExoMars program, the European Space Agency and Roscosmos, the Russian space agency, launched a space mission to the Red Planet in March 2016 to analyze the methane gas known to be present in the Martian atmosphere. In our own atmosphere, methane, the chief component of natural gas, comes mainly from biological sources, either ancient, as in oil, shale, and coal deposits, or modern, produced by rotting vegetation, belching cows, and microorganisms. However, there are also geological sources of methane, such as volcanoes and inorganic chemical processes. On Earth, at least, biological methane contains more of a light carbon isotope than geological methane, allowing the two to be distinguished. The ExoMars scientists thus hope their analysis might reveal the presence of life processes on Mars. However, the interpretation of the evidence will be crucial. One commentator says, quotes, measurements of methane on Earth suggest that methane originating from geological processes, as opposed to biological processes, has a distinct signature in hydrogen and oxygen isotopes. But I've always wondered if we were able to interpret what this means on Mars. For one thing, Mars is greatly depleted in light hydrogen versus deuterium. In other words, you can't apply Earth criteria to another planet which has a very different composition in its atmosphere. Another correspondent points out that there is an abundance of methane in the atmospheres of Neptune and Uranus, neither of which are likely to harbor life. A follow-up ExoMars mission planned for 2018 will drill 2 meters into the planet's surface to seek evidence of subsoil life. This is thought to be necessary since recent evidence suggests that the surface of Mars, irradiated as it is by ultraviolet light, is toxic to life on account of oxidizing chemicals present there. The ExoMars scientists may be strongly tempted to find, and I put that word in quotes, to find evidence of what they are looking for, sincerely interpreting their findings to fit their hopes. But even if they do find bacterial life on Mars, will it prove that life evolved there independently? Not at all. In 1996, there was great excitement when NASA claimed that a small rock found in the Antarctic had been ejected from Mars by meteor impact and had finished up on Earth. The basis of this claim was that minerals and small gas occlusions in the rock had compositions characteristic of Mars. Furthermore, examination of the rock and 2 other meteorites from Mars revealed chemicals associated with life on Earth and microscopic features that resembled fossilized bacteria. However, a 2006 article in space.com explains the reality. It was a science fiction fantasy come true. 10 years ago this summer, NASA announced the discovery of life on Mars, showing magnified pictures of a 4-pound Martian meteorite riddled with wormy blobs that looked like bacterial colonies. If the results are verified, pronounced the late Carl Sagan, it is a turning point in human history. 10 years later, the results have not been verified. Skeptics have found non-biological explanations for every piece of evidence that was present on August the 6th, 1996. Close quotes. The important point in this instance is not that NASA's claim lacked credibility, but that both they and their critics agree that the rock, along with 33 other known meteorites, did indeed come from Mars. If this is true, could not the return journey from Earth to Mars also be made? Might not meteorite impacts on Earth have ejected material which arrived on Mars carrying a complement of Earth bacteria? After all, Earth is a bigger target for cosmic bombardment than Mars. If rocks can reach Earth from Mars, they can surely also reach Mars from Earth. Martian bugs, even if found, will have to exhibit an alien chemistry of life to prove that they are not immigrants. Subheading: SETI and the cosmos. But let's return to the wider history of SETI. In March 1955, John D. Krauss published in Scientific American a proposal to scan the cosmos for natural radio signals using a radio telescope. 2 years later, and funded by $71,000 from the National Science Foundation, Ohio State University began constructing a radio observatory called Big Ear, which later undertook the world's first continuous SETI program. On 15th of August 1977, Jerry Amon, a project volunteer at the observatory, observed a strong signal and wrote, quotes, "Wow," close quotes, on the recorded trace. Unsurprisingly known now as the WOW signal, some enthusiasts considered it the best candidate to date for a cosmic radio signal from an artificial source. However, additional searches have failed to reproduce the observation, and recent investigations suggest that the signal was caused by a passing comet. One of the best-known SETI programs began in 1960, when Cornell University astronomer Frank Drake launched Project Ozma in honor of Frank Baum's fantasy Queen of Oz. Drake used a 26-meter radio telescope at Green Bank, West Virginia, to examine 2 stars, Tau Ceti and Epsilon Eridani for radio transmissions. He chose to scan at frequencies close to those of hydrogen and hydroxyl spectral lines, frequencies an alien race might choose because these two chemical species are the most common in the universe. Result? He found nothing of interest. Efforts to detect alien life were not limited to the USA. Russian scientists also took a strong interest in SETI during the 1960s, using omnidirectional antenna to look for the powerful radio signals from outer space. Space scientist Losif Shklovsky wrote a seminal book, Universe, Life, Intelligence, published in 1962, which was followed in 1966 by American astronomer Carl Sagan's best-selling book, Intelligent Life in the Universe. In 1971, NASA funded a SETI study that involved Drake, Bernard Oliver of Hewlett-Packard Corporation, and others. They recommended the construction of a radio telescope array with 1,500 dishes at a cost of $10 billion. $10 billion. Known as Project Cyclops, the proposal never saw the light of day, but the report was a major influence in much of the SETI work that followed. Subheading: The Cost of SETI, the Search for Extraterrestrial Intelligence. It may come as a shock to learn just how much money is currently being spent on the search for extraterrestrial life. The ExoMars program referred to earlier, for example, has a cost cap of €1 billion. The European Union is also building the world's largest optical telescope in Chile, with the search for extraterrestrial life as a primary objective. The construction cost is estimated to be at €1.055 billion, and the operations are planned to start in 2024. The European Space Organization, the official publicity states, quotes, "The European Extra-Large Telescope will answer fundamental questions regarding planet formation and evolution, and will bring us one step closer to answering the question, are we alone? Apart from the obvious scientific interest, this would represent a major breakthrough for humanity." For many years, the US government provided funds for SETI projects, but this ceased in 2011. However, in July 2015, a new initiative was launched under the title Breakthrough Listen, a 10-year project with $100 million funding to search for intelligent extraterrestrial communications. In a substantial expansion of earlier efforts and deploying methods not previously used for the purpose, Breakthrough Listen has been described as the most comprehensive search for alien communications to date. The project will use thousands of hours every year on two major radio telescopes, the Green Bank Observatory in West Virginia and the Parkes Observatory in Australia. The automated planet finder of Lick Observatory will also search for optical signals such as laser transmissions. In yet another SETI development, ABC News announced in March 2016 that the world's largest radio telescope was nearing completion in the southwestern province of Guizhou in China, and in fact it did begin to operate on the 25th of September 2016. The 500-meter aperture spherical radio telescope will apparently be used to search for signals of alien life. According to the authorities, more than 9,000 people have been forced to move from the area to create a quiet electromagnetic wave environment. This radio telescope, built at a cost of $0.2 billion, dwarfs the currently largest radio telescope, the 300-meter instrument at the Arecibo Observatory in Puerto Rico. So, where is everybody? That's a new subheading. The failure of SETI to produce any return on investment naturally raises questions. If there are billions of Earth-like planets out there in the universe, as many claim, and if intelligent life arises whenever the conditions are just right, where are all these advanced civilizations hiding? Those concerned are ready with answers. In an interview posted in TechCrunch in February 2016, journalist Emily Calandrelli asked SETI astronomer Jill Tarter why we haven't found intelligent life yet. In reply, Tarter offered two explanations. Firstly, quotes, "The universe is vast, and we haven't been able to look everywhere yet. With our current technologies and the time we've dedicated to SETI, we've only scratched an incredibly small portion of the universe for intelligent life." Close quotes. Secondly, quote, "We may not have found intelligent life yet because we're stuck with the physics and technology that we have in the 21st century. We may not have invented the right way to do this yet." Close quote. In brief, then, we're stuck with a big universe and rusty technology. There's not much we can do about the first problem, but Tarter is more hopeful about the second. She suggests that, quotes, "In the near future, SETI scientists will be able to search for intelligent life in pools and lakes on exoplanets." Close quotes. That would surely be the biggest fishing expedition ever undertaken, but catching fish may prove difficult. However, SETI supporters are born optimists. Witness how Jill Tarter thinks the meetup would go if intelligent aliens, not just their radio signals, ever arrived on Earth. Citing Harvard University psychologist Steven Pinker, she claims, close quotes, "Pinker's work suggests that humankind is getting kinder and gentler as we evolve. He has noted that today we may be living in the most peaceable era in our species' existence. You will be forgiven if you hadn't noticed that." Stephen Hawking was probably nearer the truth when he said, quote, "If aliens visit us, the outcome would be much as when Columbus landed in America, which didn't turn out well for the Native Americans." Close quotes. Subheading: So why bother? Whether or not these expanded SETI efforts will yield any results is doubtful. But whatever amount of money is spent in the attempt, So why does anyone bother? Clearly there must be strong motivation behind the search for extraterrestrial life to justify so huge a cost in time, money, expertise, and nervous energy. Let me respond by matching Jill Tarter's two answers by two of my own. I suggest firstly that we persist in seeking this tiny needle in the cosmic haystack because the human race is incurably curious about the universe in which we live. It is this curiosity that drives exploration of all kinds, whether geographic, oceanographic, scientific, psychological, or any other kind. Asked, quote, "Why did you want to climb Mount Everest?" Close quotes, George Mallory, who died attempting to scale the mountain in 1924, famously replied, quote, "Because it is there," close quotes, adding, "Everest is the highest mountain in the world, and no man has reached its summit. Its existence is a challenge. The answer is instinctive, a part, I suppose, of man's desire to conquer the universe." Mallory's insight regarding man's desire to conquer the universe fits uncannily well with the modern preoccupation of SETI. We appear to be hardwired with a need-to-know mentality that goes far beyond the curiosity that proverbially caused feline fatalities. This, in itself, tells us something important about the nature of mankind and reflects the biblical command to man, sometimes called the cultural mandate, to have dominion over the created order. But I believe there is a more focused reason for the insatiable search for life out there, namely the need to understand ourselves. We need an answer to the psalmist's question, "What is man?" And many believe that the discovery of intelligent extraterrestrial life would give us one. Of course, finding bugs on Mars, small, flat, or otherwise, is quite a different matter from getting an email from an extraterrestrial. But atheists argue that either discovery would tend to favor the claim that humanity is an uncreated accident of nature that could happen anywhere in the universe given the right conditions. But if SETI continues to prove unfruitful in spite of all our efforts, we may well have to conclude instead that as far as we know, humanity is unique on a cosmic scale. In any case, of course, the atheist's logic is flawed. If God created man on earth, there is nothing to stop him creating life elsewhere in the universe, and nothing to prove that he hasn't already done so. If life were to be found elsewhere in the universe, it would prove nothing concerning human origins. But as long as skeptics think that such a discovery would be a nail in the coffin of creation, they will pursue it with vigor. Equally, a failure to find extraterrestrial life, intelligence or not, proves nothing in itself. Mankind could be both accidental and still apparently unique. But given the arguments considered earlier about the supposed abundance of Earth-like planets, a unique humanity would imply something more like a miracle than an accident. Well, there we end the first part of Chapter 3, and the next episode in this podcast will complete the chapter. Thank you for your attention.